In this video we'll program the pumps as pump 1 primary, pump 2 secondary and pump 3 emergency pump, or primary, secondary, backup, or whatever you want to call it. Pump 1, if it fails, pump 2 should start. If pump 2 fails, then pump 3 should start. So let's do that. We'll use the outputs PO1Y, the command to start, and the failure outputs, the YF. We'll combine those and make some logic to start the other pumps. So we'll use the Y and YF on pump 1 and pump 2. We'll see how it goes from there. Let's make a folder for FBs. I'll use function block this time. I don't have any specific use for any memory, but just in case, doesn't really matter that much. I'll make a block for it and call it FB coordinator. Let's use text once more. So we'll need our inputs, pump 1 command and pump 1 failed. Same for pump 2. And our outputs should be starting pump 2 and starting pump 3. So let's find some pins that should do that for us. Earlier we used the low level sensor for the LSL pins, the lock safeguarding low, to turn off the pumps. So we could use lock safeguarding high. We also have the option of using force safeguarding, which is slightly different. Let's see, that's on the block itself. So we have lock safeguarding and force safeguarding, the main difference being that the template is locked in manual mode while in force it's not. So let's use force safeguarding high this time to force the pumps to start if there's a fault on the pump that's going to force it. So FSH, so we're going to force pump 2 if we need to, and the same for pump 3 if we need to. So if we want pump 1 to run, but there is a fault on pump 1, then let's force pump 2, else don't force. And similarly, if pump 2 is supposed to run but pump 2 fails, force pump 3 to run. And that's it. We didn't use any memory this time, just reading inputs to write outputs. So the outputs are purely based on the inputs, so there is no need for memory, but it is a function block, so we could use static memory if we wanted to. So now let's use it. Skip the long name. And since this is a function block and not a function, it's going to need to declare a memory for it. So let's just use FB coordinator 0. Now it auto declared it for us. Then we need to connect pump 1Y, pump 1YF, pump 2Y, pump up, let's expand this. YF. Gets messy pretty fast. So let's try and help ourselves with connection marks. Make a source so we can try and avoid the worst lines, make it a little prettier. Give it a name. Something like that. And the other one. An update name. Now we can get these. Ah, come. Doesn't want to. That's annoying. There we go. That's the pump 2 for safeguarding high. And then we need the other one. Oh, that's a mistake. For pump 3. This one should obviously be on pump 2, not pump 1. So where is the FSH? Oh, come on. And the last one. Find FSH. Try and make it pretty. Something like this. Not too bad. There. So now, if pump 1 is supposed to start, but it's failed, then pump 2 should start. Force safeguarding high. And similarly for pump 3, if that one needs to start, it should be forced high. If this one from last time, where we used the locked safeguarding low to stop the pumps, if the water level is too low, this should be the master of the two. So if we force the pumps to start, they should still stop if there's not enough water. And then I've added the options. Let's just take it from here. On the parameters for the pump SPEs, I've added actions. If there's an external fault, then the pump should try to keep running. If there's a loss of the enable signal while running, it should try to keep running, and the same with the feedback signal. The feedback signal is the one that we're gonna simulate a fault on. We're just gonna keep them always false, so the pumps will never get the feedback they want. So we'll need to start the secondary and the emergency pump. Let's download this. See if that's good. Looks okay. The simulator is running, same as last time. Now let's just close and open that one so we can. There we go. Now we're gonna do this. Let me turn it off and then turn it on again. I'll keep pump 1 and 2 feedbacks always low. So from the simulator, I'm simulating a feedback signal, a pump running confirmed signal that's never going to go high. It's forced low, so it's never going to get the confirmation it wants. So there's not a low level alarm. All the pumps are stopped. Low, low, low. So if I try to start pump 1, it's gonna fail. Should then try and start pump 2, it's also gonna fail, and then it should start pump 3. The failure is the feedback signal is not coming through. The pumps are actually running, but the feedback signal is lost. So let's try it. There's a feedback failure. There's a safeguarding failure on this one. And this one also started. Now they all stopped again, since the low level alarm was high. It was high because the level was too low, the alarm was high, and all the pumps stopped. And now the level is increasing again. So let's see if we can slow it down and do it again. Just close and open this one. Let's fully open the manual valve and then try again. Let's reset the alarm or confirm it, if you want to call it that. Starting pump 1, let's see what happens. Pump 1 had a feedback failure. Pump 2 didn't start either, it's got a safeguarding failure. Pump 3 is running. Difference here is that there is a feedback failure on pump 2, but the safeguarding failure is more important, or it's set to be more important. So it looks like it's working. And if we remove the error, just unforce everything, there the feedback signal is back. There's no alarms, all the pumps are running, and we can now control them as normal. So that's one way of creating a primary secondary, let's call it emergency, primary secondary emergency pump setup using these templates.